Here's an example of an application of law of sines. The bearing of a ship from a lighthouse was found to be north 18 degrees east. After the ship sailed 5.1 miles due south, the new bearing was north 30 degrees east. Find the distance between the ship and the lighthouse at each location. To do this, I'm going to look at the following picture. So here is the ship at the beginning. We know that the bearing of a ship from a lighthouse was first found to be north 18 degrees east. So what does that mean? So if the lighthouse is down at A here, we know that if we draw a vertical line from A, that this angle right here better be north, because that's why I did north, 18 degrees east. So that is the distance, or the bearing, from A to B. Then what happened? Well, then the ship sailed 1.5 miles due south, so we know that there are 5.1, I don't know why I keep on doing that. We know the distance between B and C, or the A distance, because that's across from the angle A, is 5.1. Finally, we know that this new bearing was north 30 degrees east. So if I choose a new color, say green, we know that this bearing of this means you draw a vertical line from the lighthouse going all the way over. We know that's 30 degrees. So to find angle A, we have to take 30 minus 18 degrees, which is 12 degrees. So that is angle A. You can also find angle B, because if I extend this line this way and extend this line this way, then we know that these two angles right here are equal. So that's 18 degrees. Now these are vertical angles, so that's also 18 degrees. So we know B is equal to 18 degrees. Therefore C, because we have a triangle, better be 180 minus the 18 minus 12. Or 18 minus 18 plus 12. So that would be equal to 18 minus, 180 minus 30, which is 150 degrees. So that would be the C. So now we know all three angles. So let me go ahead and erase that mess here, because we have the three angles. Now we're looking for the distance. I guess I erased too much. We should put a 5.1 here. What we're looking for is this distance C, right? The distance between the ship and the lighthouse at each location. So let's first find C, which is the distance from the ship to the at the beginning. C is the distance from ship at the beginning to the lighthouse. Okay, so let's go ahead and do that, because we know that we can find C by saying that the sine of C over C is equal to the sine A over A. Sine C, we know what the angle C is. It's 150 degrees. C is what we're looking for. Sine A is 12 degrees. And across from A, we know that's equal to A. That is equal to 5.1. So if we just cross multiply, and divide both sides by sine of 12 degrees, we get the value of C. C is approximately 12.3. It asks us to round to the nearest tenth. So if you actually look at the number, it's 2648 if you do this on your calculator. So to the nearest tenth is approximately 12.3. And that would be in miles, since the 5.1 was in miles as well. Now the very last thing we need to do, because they ask us to find the distance between the lighthouse and the ship at each location. So we found this distance, C. Now we need to look for this distance, and I will call that B. B is the distance from the ship at N to the lighthouse. Okay, so how am I going to do that? Well, I'm going to use the same formula, but now with B's. You can do sine of C over C, but just to show you the difference, you could do B over sine of B as well. Because that's what we're looking for is B. So then I do something that we already know. I might as well do the same one that we did before. What is that? A over sine of A was known before. So if I plug those values in, B is what I'm looking for. Angle B is 18 degrees. A, right? So if you have the A now needs to be on the numerator since the B is on the numerator, and that would be the 5.1 over the sine of A, which is 12 degrees. So now you could just multiply both sides by sine of 18 degrees, so you get 5.1 sine of 18 degrees over sine of 12 degrees. Let's just put arrow there as well. That is approximately equal to, if you use your calculator, 7.431, so forth. But they ask you to round to the nearest miles again, or sorry, nearest tenth. So it's just 7.4 miles is the second answer. Hope that helps.